Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
All right. Welcome to the latest episode of Lunch with Tech Leaders. My name is Jason Brown. I'm a cloud solutions architect with Right Brain Networks, and I'm your host for today. Joining me is software and data consultant Tom Kowalski.
Hello.
Hi, Tom. And also joining us, we have subject matter expert and recurring guest on the podcast, Preston Fraser, a senior software engineer from the Interoperability Institute. Welcome back, Preston.
Happy to be back.
In this episode, we're going to pick up where we left off from the last episode in our serverless series, building a serverless API. So in part 1, we went through the scenario where we were tasked with building a simple API that was using only serverless components. And we discussed what options available to us, why we would choose one option over another, and we went through the thought experiment of just designing the architecture for our API, making some of those decisions. And if I remember correctly, we had gone with the assumption that we were working off of AWS, building a simple Python REST API using API gateway backed by AWS Lambdas. Does that sound right to you guys?
Sounds about right. No.
Yeah. There's other nuances, right? If you think about the different workloads or whatever, but yeah, it's a good baseline to start at.
Yeah. So I know last time we mostly focused on comparing and contrasting a lot of the options when it comes to the compute layer. So for this episode, I'd like to kind of dive into other kinds of components that we'd want to accompany with our API. So the data store, caching mechanisms, asynchronous components, things like that. So I guess we'll kick it off with the persistence layer data store. So I guess we'll start with you, Tom. How do you approach selecting a database solution for web apps such as the one we built thus far? So what's the criteria that you evaluate before coming to a decision?
Yeah, again, like I always like to say, right, it depends on the workload and the team, really, what they're more familiar with. Now they're more familiar with the NoSQL or more relational database approach. There's not very many options. There's Aurora serverless on the more relational side, but even that isn't truly serverless in my book because it doesn't scale down to 0. But depending on the workload, my go-to is usually Dynamo, and yeah, that just works for me. But again, right, it depends on the team. Are they familiar with the NoSQL data modeling, and especially right, are they comfortable doing like a single table design, right? If the workload can handle that, if it needs to have that really low consistent latency, can they handle designing like a single table design? So yeah, it depends on the team, but usually Dynamo for that persistence layer is my go-to.
All right. How about you, Preston?
Yeah, I mean, I'm in the same ballpark as Tom. That's a great choice to start with first, I think. If you can make the data model work in Dynamo, that's going to be probably your cheapest cost and your easy integration. I would say Dynamo tables, the configuration for those is a lot more simple than an RDS instance like Aurora MySQL or Postgres or that road. Again, when we're talking about data model, what are we trying to do with this API? Maybe we're looking for some records associated with a user or something. So it could be a model that's pretty easy to just find the primary key and then pull the attributes from Dynamo for that user or whatever our scenario is. And there are some ways to have multiple Dynamo tables and maybe do some kind of build some kind of architecture where you're not joining the tables, but you're essentially, linking the primary key or the partition keys, as they're called in Dynamo, together to kind of simulate some kind of relational structure. In terms of, there's a reason why relational databases exist. It's for doing those kind of joins with like data. So that's good. But if you don't have to do that, I think sticking with, Dynamo is going to be a quick way to go and get you some data stored, be able to look it up on a partition key or secondary indexes. There's other data stores too, but those are probably more of like a niche use case. I'm thinking of things like, if you want to use a graph database, AWS Neptune is a solution for that. But that's kind of more of a specialized use case. You'd use that. We all know Redis and love that. An in-memory database. AWS provides services to set up that kind of database to give you like lightning fast transactions. That's also another way to go. Redis, I always talk about, is kind of a build your own database type of situation. So it's definitely got a good place for certain workflows. But there's a lot we can connect to from our compute engine, Lambda, a lot of integration there. So we're not going to be limited on what data source we can choose. But let's say we go with Dynamo.
All right, awesome. So we can assume Dynamo moving forward. Just before we move on completely, though, so let's assume that we were using or had a need to use a SQL database, right? So with Aurora, there's a lot of different flavors. I mean, does that matter still, picking the specific flavor? For example, like Postgres or MySQL, et cetera, for the SQL engine. Does that matter as much, or I guess what's the driving force behind making a choice like that? And we can, I guess, start with you, Tom.
Okay. Yeah, again, it depends on the team, right? If you're using Aurora, it's, behind the hood, it's that Aurora engine, and it's just the, syntax that's really changing with Postgres or MySQL. So it just kind of depends on the team and what they're comfortable with, and does their adapters, their data adapters support that engine? And then, we're in a serverless realm, can you leverage the data API, or some type of proxy so that your Lambda functions don't, it doesn't all have to be in a VPC, which, it can make it slower, can make, the security different, right? There's those trade-offs of, having to worry about, network security versus now, going to more of a like IAM model. So yeah, it really depends on the team and the workload. But yeah, there's a lot of options, and I tend to abstract away as much as I can. And so wherever that takes me, and thinking about where it might go in the future, you don't want to over-engineer, but if the project does get bigger, or depending on the workload, think about how it might grow. But yeah, you want to abstract away as much as you can, right? That's the idea of moving to the cloud, going to serverless.
And you mentioned the, your data model maybe growing or something like that. And that's always one of the fears I have about using relational databases, is when, you come to the time where you need to add more columns or you need to change the data structure. I don't think anybody really likes migrating a SQL database. It definitely gets harder the larger it becomes, which is another reason to use something like NoSQL, where adding, new attributes is very simple. It's elastic, and you can do that. One of the other considerations that I just thought about with, say like NoSQL or relational databases, are the amount of connections you have going to those databases. I think with our example application where we have an API gateway and a Lambda, I don't think we were thinking about having a large amount of traffic going through that. Maybe we were thinking like it would be the back end for a website or something. So depending on how popular our website is, it's going to be how much traffic we have. But when we're talking about, getting to thousands of requests per second, so, when thousands of invocations of our Lambda per second or per minute, that means there's potentially that many requests to the database. And we got to worry about connection handling, connection pooling. AWS does provide, I think it's a connection pool handler for relational databases. With like NoSQL and Dynamo, it's a little more friendly towards scaling, but there's also some caveats with that too. If you try to scale too fast, you could get kind of scaling warnings, and you could get rejections on connections. So making sure that your database is able to handle the amount of connections you're going to need or the amount of requests is an important thing to worry about when building your architecture.
All right, excellent. So yeah, let's say for this particular scenario, we've settled on Dynamo. And I guess just to add more to the type of the workload, let's just say we're building a very simple employee organization app, like we're organizing our employees for our work. So an employee could have like a name, a role, etc. And we want to store like a fact sheet for every single employee that we have in our organization, right? Choosing Dynamo, I think, would be appropriate for that, giving us some flexibility over other attributes to expand on later. But also, so having that flexibility, but also being able to do the job that we needed to do for our CRUD application for our REST app. So let's say now a request comes in for updating the functionality of the app, right? And we need to we have to have some kind of a process that's working behind the scenes, let's say onboarding, right? When we add a new employee to organization. And we need to have some kind of processing that's happening behind the scenes that wouldn't really be appropriate for a synchronous web API, right? So we need to decouple that from this application, but also make it so that it works together in tandem with our REST API. So where do we even begin here? So what are the potential options we could use for being able to offload some of that to a secondary component that's working asynchronously?
So I think you're saying it's something that could be triggered from one of our requests to our API, but we don't need to wait for it to finish.
Correct.
There's a few different methods that, AWS provides, at least to offload that work. One of those is simple queue service, SQS, putting a message in that queue for another process to pick up, or SNS, simple notification service, where it's not a queue, but it's basically raising a notification that something can be listening to take that work on. And both of those are essentially, send the message off and then keep processing. You don't need to wait for it to come for a response for that. Or you don't need to wait for that work to be done. You're basically offloading that to another process downstream.
Okay. There's other services too. It depends, right? How complicated is it, right? Is it more orchestration versus coordination? There's a great article by Jan Chewy. I'd suggest reading it. But there's other services like Event Bridge or step functions that can help you out with kind of that orchestration and coordination. But you want to start simple. So if it's just handing it off to another one, and it's just if it's just one asynchronous task going on is one thing, but if it's a lot larger, then it might be easier to leverage like Event Bridge or step functions where there's a lot of steps, a lot of waiting involved, maybe even manual processes, a lot of integrations with third parties. So AWS provides a lot of options for that, but I suggest starting simple.
And, again, starting from a Lambda function, we have a lot of options for integration. There's ways to invoke almost any service from a Lambda. That's your compute engine. So, we can even do Kinesis too, which is data stream for kind of real-time processing, which is quite quick to send data to as well. It's another option. So plenty of ways to offload work to be done.
Okay, so let's say we're starting simple with SQS, and we're using Lambda to process those SQS messages. So we can offload those onto our asynchronous process. So you both mentioned a couple different things like step functions or kinesis. Like, are there any particular scenarios that would be more well suited for one versus the other?
Like I mentioned, that coordination versus orchestration, and it depends on how complicated it gets. I don't want to, I can't, take away from that article, but I recommend reading that. It's really helpful to help you to think about it. And I'll post it if you're in our Discord, the Great Lakes Tech Leaders. I'll have it there for anybody listening.
Both of those I think have a great different usages in your architecture. A lot of times we use Event Bridge as a trigger or, events that happen. That's kind of obvious, but like a cron task or something would run every so often and kick off events to run. That's one big usage of Event Bridge, but there's other ones too. I see step functions again, like Tom said, is orchestrating some kind of overall process and kind of tracking the steps as you go through, the processing. Maybe you're processing a file and you got to do different steps to take it apart or do validation, things like that. So kind of file processing is something that my company likes to use step functions for, so we can track the progress as it goes, but it's all orchestrated in one area. I think in our example here, maybe we're talking about there's maybe a more time expensive process that needs to happen, and that's why we're kicking off this extra task. So maybe we're going through and we're doing some kind of web service lookup, or we're doing some kind of web service validation. Maybe we're going to go validate some credentials for our employees at like a Secretary of State or, at some other entity. I don't know. We'll make up something fun like that. And so we need a longer process to run and validate that, or something that's not critical at the time. So, kicking that off to a queue, maybe we can have a downstream, another called Lambda that reads from that queue, and it processes that work, each record as it gets to it, in its own time, and it can take as, whatever time it needs to do. So, I think something like that, put something in the queue and let a Lambda consume the tasks from that queue as available.
All right, awesome. Yeah, so let's assume now that with the asynchronous process, we have our organization growing quite a lot, and Dynamo is getting hammered with requests, just absolutely hammered, and we want to ease the load, and we're thinking about implementing a caching mechanism for this. Previously, you mentioned Elasticache with Redis, I think. There's also Elasticache using Memcache. Would either of those be viable options here, or are there other options available to us using Dynamo?
I would start with the why first. What is the app? Why is the application hitting it? Does it need to be making those requests? You need to start there before you kind of over-engineer, something on the back end. It could be something on the front end that's broken, and it usually is, right? It doesn't need to be making those requests. So I just got to throw that out there. You should start there. But then from there, it depends on what the information is. You don't want to maybe over-engineer the, entire, your entire back-end persistent storage if it's just one call that's being hit over and over again, right? Like one piece of information. Maybe that would make sense to cache it at different layers, right, along that network. Maybe it is caching it within the front end itself, either on an app or the browser, or then going from there, like an edge location like CDN or CloudFront, possibly storing something there. And then, down the line, you can put stuff right in front of Dynamo. There's in-memory storage that you can, throw in front of Dynamo. But yeah, it depends on that workload. So, I got to preface that before I, say why is it being hit, start there.
And certainly if it's something that's not, data's not changing like in real time, that's a great scenario for caching data. Maybe you're pulling down configurations from a Dynamo table, or you're loading records that are, they're not going to change very often. That's great times to cache data. So you have them cached locally in your Lambda container, and you don't have to make those requests up to Dynamo every time. That'll save a lot of requests and data transfer. But of course, there are scenarios where, hey, data is being updated in real time, and we do need to check every time that what the most up-to-date record is in Dynamo. So if you're having those issues where you are making too many requests and Dynamo can't scale fast enough for you, that's a time to, maybe rethink your architecture and look at something maybe like a Redis, which you can have a lot more connections and you can scale that service up manually. Dynamo is something you can purchase like provision concurrency for that, but I don't think it's as flexible as being able to manually scale up like an Elasticache instance. And so we've actually had that kind of situation happen at our company where we were using Dynamo, but we needed a better data store because the data was changing too fast in it. And so it wasn't really fitting our use case. And so we did move to Elasticache with Redis, and that gave us a lot better performance. Costs a lot more money, but it gave us the proper performance for the workflow that we needed to do.
And something else that you mentioned that, made me think about it, you're saying you could cache it right in the Lambda function itself. Another thing that, you should look into, if it's just a simple read, is not going through the compute layer. If you're using API Gateway or the GraphQL, the AppSync offering that AWS has, it might make sense to go directly from those APIs to Dynamo or your data store directly, right? You can do that authentication there. And if it's just a read, you really don't have to validate. There's no input to validate with logic. And yeah, just pulling directly from there can save you a lot of money. And instead of going to a compute layer like Lambda first.
Right, exactly. Like you said, API Gateway and AppSync have integration with several different AWS services, including Dynamo, Step Functions, Kinesis. And so that can take the compute layer right out of it. Of course, if you get more complex with data validation or some more complex logic, that might not work for you. But yeah, certainly a great option.
Yeah, they started making it easier. I forget which one allows you to use JavaScript, but if you have to do some logic, we might have to start using like VTL, which can get a bit hairy to write, especially if complex logic.
Excellent. All right. Great points. And yeah, we are coming up on time, so I'd just like to save a little bit of room for final thoughts. And we'll start off with you, Tom. Final thoughts?
Yeah, it's, really think about how the data is accessed all the way through. A lot of times you just think, all the data go right through the, API compute layer down to the same persistent storage for everything and, back up. But you really want to think about the data journey, right from the website, using how it's stored locally on the site or device, or edge locations. Is it, do you need to go multi-regional? Do you have to worry about the data localization or things like that? So yeah, you don't want to over-engineer, but you think about those options that you have. And yeah, it's not just always that one straight path, right? And it can be different, right? For the app, usually it's that one call that is 90%, 99% of everything that you may need to make faster versus, all of your calls, right? So yeah, just think about it at the different layers and, the different pieces of data where, where it can fit and make the most sense in your architecture.
Excellent. All right, Preston, final thoughts?
Yeah, I mean, definitely at the beginning, draw out an architecture diagram and play with those pieces and move them around and see what you think is going to work best. Just to add on to what Tom said, definitely think about the production load that your application is going to have. I mean, so many things can work great in dev and send in a couple requests and everything works perfect. But then once you have that production load of data and you really start seeing how long some of these requests take and how much that adds up, how much work that puts on the system, how much not only time it takes and performance, but the cost of how much it's really costing with these services. Keep that end production load in mind. I think in terms of serverless, that's really an important thing to think about is a lot of stuff will work, and cloud providers give you a lot of tools to play with, but you're going to have a specific workflow or use case or several scenarios, and you want to add up how much that's going to cost before you get it into production. And, of course, I will say, though, I feel like it is easier to change the architecture with cloud services, too, since there are so many services. It's hopefully not as big a lift to, change out from a DynamoDB to a Redis Elasticache or an RDS instance. If you have tooling set up, it's not too bad to spin up a new service if needed. So pivoting is, I think, a little bit easier with cloud services. But, architect it all out and just keep in mind you might have to change later on.
Right, wonderful. Great points all around. I would like to take the opportunity to thank both of you, as always, and to thank all of our listeners for tuning in to today's episode of Lunch with Tech Leaders. We hope you found the conversation informative and valuable. We would love to have you join us again for our next episode. As always, the episode will feature expert guests and interactive conversations, so be sure to tune in. Thanks, everybody, and we'll talk to you next time.